Hi. Our main topic is the orders lines. Um, I'm just gonna try to talk about the key thing you have to learn before learning about orders lines. As you just know, you can actually get the address of the memory using the CPU fetch function. So what do you mean CPU fetch function? Um, Inside CPU, there are registers, right? And inside these registers, there are general purpose of registers, and there's special purpose of registers. And among this special purpose of the register, there's such a thing called segment register and instruction pointer register. And the code segment register is the one who store the offset of the memory. So it's just gonna store the base address of the memory that you want to find. And this IP is instruction pointer. So it just points the where should we target. Example, we want to use some kind of instructions like pop or push, like stack vector of it, and we want to store this next instruction using this code segment register and instruction pointer. And this code segment register, if it is memory buffer, code segment register is gonna store the offset of this, and instruction pointer is the one who points it. And we're just gonna get this memory address based on that. And the formula is code segment registers the offset hex value times 16 and plus instruction pointer registers the value of it. And that is the function of the fetch. And the more interesting thing of what I learned was, I think it was really simple to get the memory address. And because the memory, there's like RAM, ROM, and those kind of stuff. And this kind of simple formula is to fetch the orders of the memory, and this kind of simplicity made me confused more. And I asked and I searched it, and this was not. Actually, this is the way to find the memory address, but not real address, not physical real address. It's just the logical address. So what do you mean logical address? Logical address, what I know about logical address is just the relative address rather than real physical address. And let me simplify this more. There's a CPU, right? We use fetch to get the next instruction, and after that, we get the logical logical address, and more, we use address decoder to get the real physical address. And this is how it works. But that is really like simplified explanation. But the thing is that when trying to learn about address decoder, you have to learn about how memory chips work. How do we define our memory chips? This is kind of very like simple example of it. Let's assume that you have a microprocessor with 10 address lines. Okay. You might give question about this 10 address lines. The address lines is really abstract, right? The address line is actually just a line. It's just the line. The reason it is line is because the hardware are basically made of these circuits, or we're still of the line. And when we try to press our computer, there's gonna be electric, and you're gonna go to the power of it, and you go to the hardware specification of the computer, and you're eventually gonna make it work. And the circuits is the base fundamental of this hardware, And this address line is among of this hardware. And yes, and this address lines is actually store the two value, which is 0 or 1. Simple, right? And let's assume that we implement or its memory space, and we use 128 times 8 memory chips. And this 128 stand for the how many address it has and how many size it has. I'm sorry, not how many, the how big is the sizes. And of course this 8 is 8 bits. And there's formula of it actually. To get the how many chips we need is actually simple. Now we given the microprocessor, the CPU, has address lines, 10 address lines, right? So this is gonna be 10. Oh, by the way, this is not real address line, it's just a really simplified line. This doesn't mean that address in real world of 10 address lines equal to not one line. This is really because we have to like make a 10 lines, but there's gonna be really complicated row, and we're just gonna specify this line. We're just gonna draw like one line, and this equals to 10 address lines, and CPU has 10 address lines, and let's assume that we wish implement or its memory space, and we use 128 times memory chips. Okay, so we have a memory chips, the chips, and the specification is 120 times 8. And the thing is that we have to know about how many is this, right? How many we memory chips need. And the simple way to get the how many chips we need is these 10 address lines is equal to the 1024 locations. And yes, the reason why it is 2 is because address lines corresponds to 0 or 1 value, so that's the 2 of it. And next is we specify how many address the memory chips has, right? Yeah, memory chips has one, so 128. Yeah, that's gonna be it. So 10,024 divided by 128 equals to 8, right? So that's why we need 8 memory chips. And that's very simple. And let me try to like give more example of it. Let's say we wanna drive it, and this is the beginning of it. Start line, and we have a car. And we have a 10 address lines. So let's say that in there's a 2 road of it. There's 2 road. There's 2 road of it, and the value is 0, 1, and there are 10 of it. So there are tens of it. So how many is the way to go to find the memory, right? And let's go to 2 square 10, right? And let's assume more than the memory here is equals to our house. You are rich and you have a house, and And to go to your house, there are 128 ways of it. Address lines. Address. You to go to your house. The way to go there requires, and there are like 128. And the size of this actually the way is equal to the rod. So there are 128 rod of it, and the size is 8 bits. So the rod is kind of big, right? And there are 128 ways for it. And based on this stuff, you have to analyze how many house that I can go when I have this kind of road specification. And to go there, we can just divide 2 square 10, and there are 128 locations or to go to your house, right? So we can just divide into the here, 128, and there will become 8, right? So that means that we have 8 houses. We have 8 houses. Nice. We have 8 houses. But the thing is that we don't know. There's like, how do I say it? You don't know get something in your house. You don't know you store some kind of fancy car or fancy money. Fancy money. It sounds weird. You wanna store something valuable in your house. Let's say this is just your house, and to go there requires some road, right? And we have to know that how many roads we have to know about to go to there. And yes, we know that there are 10 rows of it, but we have to make it sure that there are purpose of the 10 rows. What, like 5 of them is for getting this the like, how do I say it? Getting the internal stuff, because in your house there's like basement or those kind of area, right? There's an internal area or cells, and there are also just one way to get all of thing in your house, the plain all of thing. And in this computer science sort, CPU divides into some kind of purpose, 2 purpose of it, and we should guess it. How many others like that to get just whole memory or whole one chip, one house. And actually there's a formula of it. The formula is hold on. Yeah, I believe the formula is we just get the size of, right? How many size we have? There's 8 memory chips. And we just define how many chips we need. So there's 8 of it. And of course, in each rod is defined as 0 and 1. And you have to go to the 8 specific house. The how many line you need, right? And it's actually simple, because this is actually there's 2 value, right? And we times how many 2 of it. We times some kind of numerous the same value of the 2, and we somehow get the value of 8 because there's 8 chips, right? And so the formula is gonna be like 2n equals to 8, and 2 log n 8 is gonna be 3. So that means that you only need 3 address lines to get just per each one chip, one house. This also means that there's a 2 road, but we just define into 1 road and a 1 way. So there's a 2 road, 1 and 2. You can go with the first line and second line, and there are multiple of it. There are multiple. We cannot know how many way to go it, but we know that there are 8 houses that I can go. So which means that we only need 3 of it, because 2 square 3 equals to 8. Super, right? And the next, the orders for each area inside the memory, each cells, or if I try to give example of the real house, is like the basement or kitchen, those kind of stuff, the area of it. And to define it, and I believe that we assume that our chips have 128 ways to go in. So there's like 128, and the size is 8 bits. And it's very simple. To go to your house, to go to your area, we require that the road has 1 and 0, and this road has to be go with some kind of cells, right? And that's very simple. We can just do the same thing like here. So that means that we just do the log 2, and put 128, and there equals to the 7, which means that there are 7 ways to go in. But actually, without trying to make it like this kind of formula, you can just divide it 10 times 3 equals to 7. There are 7 address lines to go in. And that is really what I learned. And the most interesting part is that I thought that is kind of formula to get the size, how many chips I need in the RAM, not the ROM. But this is also valid in RAM and ROM, or those kind of memory. And this also means that this is the fundamental of getting the size, how many address line I need, how many size the memory should be. And this is the key of it. Example, so you are using RAM. You wanna specify you wanna get the size of the chips based on that. You can use this kind of formula. If you're using ROM, you can use this kind of formula. And I believe this is kind of really fascinating. So this is it. Yeah. And have a nice day. Bye bye.